In this class, we will go to the last module, that is lubrication and bearing. Let us see what is the meaning of lubrication. Already the lubrication, I think you have studied in the fluid mechanics. Okay, here important is only bearings. Let us see the definition of lubrication. Lubrication occurs because of the friction. Main purpose of the lubrication. Let us see what is the definition of lubrication. Friction is the resistance to relation motion between the two surfaces in contact. The function of the lubricant is to reduce the friction. Friction occurs because of the motion of the two bodies. To overcome this friction, we are going to use the lubricant. In this process we call as lubrication. Lubrication is nothing but lubrication is a process to reduce the friction. Okay. Any substance placed between two rubbing surfaces which reduces friction is called a lubricant. Lubricant is different, lubrication is different. Lubrication is a process. Lubricant is a substance. Okay. Types of lubricant: liquid, semi-liquid, solid. Liquid, semi-liquid, solid. Liquid lubricant are used properly when they have to be retained. Example for liquid lubricant are mineral oil, animal oil, vegetable oil, synthetic oil. Grease are a semi-liquid lubricant for higher viscosity than the oils. Then similarly, solid lubricants are also used in reducing the friction where oil film cannot be maintained because of pressure or temperature. Whenever the temperature is high, that time you are going to use a solid lubricant. Where the temperature is low, you are going to use a liquid lubricant. Remember this. Okay. Properties of the lubricant, that is viscosity, and comes oiliness, flash point, fire point, pour point, cloud point. It is not so much important. Okay, these are some properties of the lubricant. Okay. Oiliness, flash point, fire point, pour point, cloud point. Oiliness refers to wettability, surface tension, and the slipperiness. Flash point means the lowest temperature at which oil gives off sufficient vapor to give a momentary flash on introduction of flame. Already I just explained what I did in the fluid mechanics lab. Flash and fire point. The lowest temperature at oil gives off sufficient vapor to burn continuously when ignited. Pour point. It is the lowest temperature the oil ceases to flow when cooled. Okay. And cloud point. The temperature at which an oil becomes cloudy in appearance when cooled. Okay. These are not so much important. Okay. Selection of lubricant, I don't want this one. Next comes bearings. Here is important for us. Bearing is a machine member which supports, guides, and restrains the moving elements. See, the main function of the bearing is supports, guide, and restrains the moving elements. It supports, guide, and restrain the moving elements. Okay, all machineries are provided as supports for rotating shafts. The supporting device is called bearing. Okay, main function of the bearing is support. Main function is support. It is a stationary member which carries the load. Also, it carries the load. The portion of the shaft supported the bearing is known as journal. The common application of bearings are shafting in workshops, spindles of machine tools such as lathe, drilling, milling, machining, etc. See, journal bearing will be like this. Here it will be like this. Here one circle I will take. Here one circle I will take. This inside circle you called as a chip. This you called as bearing. This is your bearing, and this is called as journal. This is called as journal. Okay. This is bearing, and this is called as journal. Here, what is the definition of bearing? One thing I will tell you. All machineries are provided supports for rotating shafts. The supporting device is called bearing. It is a stationary member which carries the load. The portion of the shaft supported by the bearing is known as journal. Means here shaft will be there inside. This portion is called as a journal, and this portion is called as a bearings. Okay. Now types of the bearings. These are types of the bearings. Bearings will mainly divided into sliding and rolling. Sliding is further under full journal bearing, partial, thrust, slider, hydrostatic. Okay, just go through this table if you want. Okay, lubrication bearing depend on the direction of load applied. Radial bearing, push step bearing, thrust bearing. Okay, this is a radial bearing, this is a push step bearing, this is a polar bearing. I am using the polar here, so for the polar bearing, this is a put step or a pivot bearing, and this is a radial bearing. And next, depending upon nature of contact, sliding contact and a rolling contact. Okay, sliding and a rolling contact. Okay, sliding bearings. These are thick film bearings, thin film bearings, zero film. Thick, thin, zero. Thick, thin, zero. Thick means in which surface are completely separated from each other by the lubricant. Means here a surface will be there, here one will be surface will in between here. This will be your lubricant. Okay, this will be everything will be your lubricant. This one whole body will be a lubricant. Then you put a thick film lubricant. Thin film lubricant means here one surface will be there, here a small here surface will be there. Between these two surface, lubricant will be there, but it will be less. Okay, this is thin. Then zero film means there will be no lubricant in between the two surfaces. One surface, second surface, there will be no lubricant in between the surface. Then you put a zero film lubricant. Okay. Next comes hydrodynamic theory of lubrication. This is very important. Hydrodynamic theory. Here, what do you see? Perfect lubrication or thick film is the lubricant that maintains complete film of lubricant between the surface of the shaft and the bearing. Already explained this one. Boundary film lubrication. A metal to metal contact can sometimes occur. Boundary film lubrication means thin, and perfect lubrication means thick and thin. Okay. Now let us see what is hydrodynamic theory. When a journal is at rest here. This is journal. This is bearing. This is journal. This is bearing. Okay. When the journal is at this is at rest. Okay, and this is a bearing. Okay, contact of lubricant is at lowest point P, at this point P, and leaving a crescent shaped space above means this space is called the crescent space. Space is called the crescent space. When the shaft rotates in the counterclockwise direction, as shown in the figure 7.3a, this is 7.3a. When the shaft rotates in the counterclockwise direction, see this is direction. Okay, it tends to move above the slightly. It's going to move above slightly, and the point will move from P to P1. This point will move like this from P to P1. As the speed of the shaft increases, this shaft increases, it carries the oil. With it from the wider space A towards the space. When the speed increases, the shaft carries the oil from this portion to this portion, that is from portion A to C, and the fluid pressure in the oil rises. Here fluid pressure will be increases. When the speed is higher, the pressure is sufficient to carry the weight of the journal. And the speed is higher, this pressure, whatever the pressure is going to build up here, it is going to support this load. Then there is no metal to metal contact. As the speed increases, this oil comes like here. This oil comes here, and this point will from P1 to will move to the P2. Okay, and this area will be more pressure. Okay, but there will be no metal to metal. But shaft is supported by being nearest to the bearing surface at point P on the outside. The point of maximum fluid pressure and position of the shaft is shown here. This diagram indicates fluid pressure. Okay, and this diagram indicates load. Okay, let's go through this properly. Thank you.